Greetings all. Today we have just a small problem here regarding a triangle and two circles inscribed, and what we have is to find the value of the green colored area. So it is an equilateral triangle with side edge of 12, so that means BC is 12, AB is 12, and AC is 12. So we are going to use that information to find the area of our green part here. Alright, so we have two circles. We will have to find these two radius of the circles and then use that and solve this problem. Yeah, I modified the prompt here, and now if we look at our sketch, we have from B to the middle here, we have 6 units, and this one will be the radius of the big circle, and this one will be the radius of the small circle, small r. And if we look at this part here, since these two are parallel, and this one is perpendicular to this one, we can say that that part here is the difference between the two radii, so big R minus the small r. So we are going to use all this information, and what we are going to do is to find the value of the x here. Now, once we have x, we can use that and solve our problem, because if you notice here, we have a big what I call a trapezoid here. We can use that. Once we find the area of the trapezoid, we can find the value of these two sectors, and then we subtract from the area of our trapezoid. We could have used other methods, but this one is another one, so feel free to use other methods to find the same results. So let's start. If we look at here, we can say that tangent of 30 degrees, of course this one is a bisector of course the 60 degrees. By the way, this is 60, this is 60, and the other one is 60 here. So tangent 30 degrees here is r over 6. That means the radius r here is equal to 6 times tangent 30 degrees. And the tangent, you know, sine 30 degrees 1/2, and sine 30 degrees is 1/2, and cosine is square root of 3 over 2. So if we do the multiplication, and we can say it is r is equal to 6 times 1/2 over 3 over square root of 3 over 2. That means we will get finally r is equal to 2 square root of 3. Okay, so once we have r, we can quickly see that the other area here, OB, is double r. Okay, and we can find r plus r here, this part here, and the other one is, okay, this one is r minus r. So if we look at these two colored triangles here, these are similar. We have the same vertical angle here of 60 degrees, and since this is 30, the other one here is 30 degrees up here. So we can use that information and find a relationship between r plus r and r minus r. And if we have the angle of 30 degrees here, we can say of course sine of 30 degrees is r minus r over r plus r. That is one formula we can use here. Okay, so if we say r minus r over r plus r, so we can say that in that situation r minus r is equal to or r plus r is equal to r minus r over sine 30 degrees or over 1/2. That means r plus r is equal to 2 times r minus r. So if we solve for r here, we can find the value of small r compared to capital R, big radius. So you can quickly find out that 2r minus r is equal to small r's plus another small r, right? Very good. So that means the big radius is 3 times the small one, or the small one is 1/3 of the big radius. So that is a very important information. And remember, we already found the value of the big radius. That means we have the small radius, that will be 2 square root of 3 over 3. Okay, so since we have that, we can find now x, because if we compare these two corresponding parts of the two colored triangles, which are similar, we can pull out our relationship, and the x here is also that part here. So we can say, if we divide x by its counterpart here, corresponding part of 6, is same as dividing r minus r by r here on the other triangle. That means the value of x is 6 times r minus r over the big radius. So we can do the calculation here and find r minus r which is equal to 2 square root of 3 minus 2 square root of 3 over 3, and that will be 4 square root of 3 over 3. So that will be capital R minus small r. Now we have to find the value of x. I'm going to use another color to make the difference because it's becoming crowded here on the screen. So x is equal to 6 times r minus r is 4 square root of 3 over 4 square root of 3, and all over big R. Big R is 2 square root of 3. Okay, so there you go. So x is equal to 4 actually. Okay, in the r minus r is actually 4 square root of 3 over 3. Okay, so x is equal to 4. So we have that, and now we go to the next screen here. Our goal is to find the red area here, and if you look at the graphic now, we have made available our trapezoid with height of 4 and the two bases, which big radius and small radius. We can calculate the area of the trapezoid, and then once we have that, we can subtract the sum of the two sectors that are colored here, the first one from the big circle and the small one from the small circle, and we can see that this angle here is 60 degrees, and the other one you saw in the previous sketch, it was 90 degrees plus 30, so it's 120. So we can find our value of the areas. So this is what we are going for here. First, for the trapezoid, we can say area of the PHOD here the trapezoid, we can say it is equal to big R, the big radius, plus small radius over 2 times the height, which would be x. Okay, so if we plug in the values, we can say that it is equal to 2 square root of 3 plus 2 square root of 3 over 3 all times x over 2. That's 4 over 2. So we do the multiplication here. We get 6 plus 2. It will be 8 square root of 3 square root of 3 over 3 here times 2. Okay, 4 divided by 2 is 2. So that makes it 16 square root of 3 over 3. So that is the area of our trapezoid. Okay, now we have to find the sum of the area of the two sectors. So we can say that is the first one, for the big one, we have 60 degrees over 360 times the big radius squared. Alright, times pi, plus the small one will be 120 over 360 times the small radius squared times pi. And now we plug in the values, and for some simplification before, you can say 60 over 360 is 1/6, so you can say it is equal to pi r squared over 6 in the first part here, plus 1/3 of the other one, pi r squared over 3. So you can plug in the values. So to separate it here, let's see, for the, so pi times r squared is 2 square root of 3 squared all over 6, plus pi times 2 square root of 3 over 3 all squared, all divided by 3. Okay, so we do the calculations. Let's simplify this. Here we get 2 squared is 4, 4 times 3 is 12, 12 over 6 will be 2, so 12 pi over 6 times, the same way here, is 12 pi over 3 is 4 pi over 9. Okay, so 12 pi over 9 divided by 1 but divided by 3. So if we simplify this, we get 2 pi plus 4 pi over 9 actually. It is 4 pi over 9. Okay, there you go. So now we can do the calculation. You can find that the value is 7.68 roughly. Okay, so now since we have that, we subtract it from the area of our trapezoid, and we conclude that our colored area so 16 square root of 3 over 3 minus 7.68. So that will give us our value of the colored area, roughly 1.56 square units. So depending on the rounding, sometimes you can find 1.54, 1.55, but this is actually what we are looking for. Thank you for watching, and see you in another smaller problem. Thank you. Bye bye.